You're out playing mini-golf by yourself, enjoying a normal, quiet Friday night. You try to hit a hole-in-one, but sadly nothing about this golf course makes sense. Just like how you reckon humans know more about Andromeda than they do about Earth's deep oceans. Well. If it isn't Kyle wondering about space again. And while you are wrong about that thought, I've been studying Andromeda, seeing as I've had the time to do so. Yes, there is nothing normal about it. Andromeda is dying. Not only that, but the galaxies orbiting it make no sense. It's missing dark matter, and the collision everyone told you was inevitable with the Milky Way might not happen at all. Much like me, Andromeda has survived something extreme. So you little while it's impossible for humans to actually travel there, you and I are going to do just that. Because most of what we thought we knew about our closest large galaxy might be wrong. So, first things first, we can see Andromeda easily from Earth. That smudge you noticed with your naked eye on a clear autumn night, that's Andromeda. Another spiral galaxy 2.5 million light years away with roughly 1 trillion stars, maybe. And for most of human history, people thought it was just a cloud of gas floating inside our own galaxy. Then in 1924, a badass called Hubble measured its distance using pulsing stars called Seifert variables, essentially measuring sticks for space, and realized it was so insanely far away, it just had to be an entirely separate galaxy, and much bigger than the Milky Way. He was right, and you see, decades later, NASA spent over 10 years taking the most detailed image ever of a galaxy outside of the Milky Way. And what did they find when they finally got a proper look? A train wreck. That's actually a direct quote from an astronomer. But why would he insult Andromeda in such a mean way? Just like how I was insulted by the doctor at my last physical when he said I needed to do more cardio. Thankfully, he changed his mind when I threatened to send him to the moon naked. Anyway, Andromeda is packed with younger stars than expected, and it also has a weird stream of stars trailing across it like scars. There's only one thing that causes this. The evidence points to a violent collision with another galaxy roughly 2 to 4 billion years ago. And the most likely culprit is M32, a compact galaxy that orbits Andromeda today, but actually looks like the destroyed husk of what was once a full spiral galaxy. Can you imagine? 3 large spiral galaxies in the local group? Wow! But something tore it apart. Andromeda. Then she absorbed it, and the impact caused a massive burst of star formation of perhaps 100 solar masses a year. Remember, the Milky Way maybe only forms like 1 to 2 solar masses a year, and now Andromeda does about 0.4. Yes, after this immense star formation, it just basically stopped. The whole galaxy has been slowly getting dimmer ever since. It seems it is already dying. And that's the second stage of things we shall discuss about how weird Andromeda actually is, and how what we thought we knew just simply isn't true or meant to be. Like how you realized you can also transform into gravity pool and abuse me and throw me into a black hole. But I've returned, and I'm using this amazing device to force you to be Kyle again. Also, we can solve this mystery I've been hyperfixated on since you banished me into another universe. No hard feelings, right? So, now that Andromeda is just sitting there quietly and going dim, astronomers have a name for this process. They call it the Green Valley. Which sounds lovely, doesn't it? Like a nice place for a walk. Let me tell you, it is not a nice place for a walk, Kyle. Like how I tricked Goose for a walk, and he's now no longer Ripped Goose, but Ripped Goose. Tragic, very sad. So the Green Valley is the transition zone between galaxies that are actively forming stars, which are called blue galaxies due to young hot stars forming, because those stars are more likely to be huge and blue. Yeah. And galaxies that have basically stopped star formation entirely and are just slowly aging and fading out are called red, because all that's left are old, dim stars. Yeah, Andromeda is right in the middle of that transition. It's not quite dead, but it is heading there. Star formation is expected to extinguish completely within about 5 billion years, and that's before anything else happens to it. Ultimately, Andromeda is running out of the gas it needs to make new stars. But to answer your most important question, Kyle, yes, the Milky Way is also in the Green Valley. Some scientists think the collision between us and Andromeda, if it happens, and we'll get to that later, might actually trigger one last burst of star formation before everything goes dark forever. Much like how I will make you feel the pain of 1,000 black holes for your betrayal. You should have seen me training, Kyle. Just like that fresh divorce energy, you have to go to the gym and become your best self. Even though you probably should have been your best self in the marriage, you know? Life is weird that way. Weirder than the fact that you might notice we're about halfway to Andromeda and already we are inside its halo. And I don't mean the dark matter halo. Yes, this is stage 3 of Andromeda's weirdness that we were wrong about. See, Andromeda has an atmosphere. Not like Earth's atmosphere, although I think American Bear followed us and is flying around in it outside. Well, that's weird. But no, it's a massive, nearly invisible shell of hot diffuse gas surrounding the entire galaxy. And when the Hubble telescope finally mapped it properly, it was absolutely enormous. In some directions, it stretches from 1 to even up to 2 million light years. Andromeda is 2.5 million light years away, and the halo extends more than halfway to us, which means we are already inside it. Right now, the outer edges of Andromeda's atmosphere and the outer edges of the Milky Way's atmosphere are already bumping into each other, mixing together. Like two people in an elevator who refuse to acknowledge the awkwardness. God, I hate that. And then I dropped my yo-yo and she freaked out. But then I showed her my yo-yo tricks and we ended up at the bar and then... So this halo isn't just big, it's heavy. And here's the even more not-so-normal thing about it. Hubble estimated this halo contains roughly half the mass of every single star in Andromeda combined. Not in the form of stars, mind you, just in floating near-invisible gas. The halo is enriched with heavy elements too, like carbon, silicon, oxygen, and has blasted it over billions of years by supernova exploding inside Andromeda's main disk, throwing material so violently that it escaped the galaxy entirely and just floated out here. Incredible. But we've known Andromeda has existed for 100 years. We've pointed telescopes at it, we've studied it, and this whole time, this entire time, nobody knew that the halo was there. Nobody knew it was already touching the Milky Way. Do we even know what Andromeda actually is, and what else don't we know? Or even worse, what more could we be wrong about? Like how I was wrong about listening to that salesman when he told me my new blazer was made from the finest chin hairs of a Peruvian mountain goat. I just wanted to impress a girl from the elevator, you know? Sadly, she ended up being more impressed by my Lego collection. Ah, bliss. She's amazing. But none of that happiness prepared me for this, Kyle. Getting closer to Andromeda, the 4th stage. You know dark matter, right? The stuff that makes up most of the mass in the universe, but can't be seen, touched, or directly detected. It just exists exerting gravity. Well, here's the thing. We know it exists in and around every galaxy largely because of Andromeda. In 1970, an astronomer called Vera Rubin was studying how fast the gas clouds at the edges of Andromeda's disk were rotating. And they were spinning too fast. Way too fast. There shouldn't have been enough mass there to hold them in orbit at that speed around the big supermassive black hole in the middle. Like when I rocked a Beyblade at Ripped Goose's funeral as the ultimate sign of disrespect, which I think he would respect because of how much he disrespected me in life. Poetic. Anyway, Andromeda's disks had something invisible helping it spin by providing extra gravity. That something was dark matter. Andromeda was the galaxy that gave us some of the first real evidence it existed. So you would expect Andromeda to be absolutely packed with this stuff, right? Well, that's what we thought about Andromeda for over half a century. Until in February 2025, a team from the Paris Observatory published the most sophisticated model of Andromeda ever built. They ran it through the full history of the galaxy, including the collision 2.5 billion years ago we talked about with the M32 galaxy. And when they calculated the total mass of the entirety of Andromeda, it came out at 450 billion solar masses, which sounds enormous. It is enormous, but it's 2 to 4 times lower than what we previously thought. Remember I said at the beginning it's about 1 trillion solar masses of gas and material? Exactly. And when you run the numbers on how much of that mass is ordinary matter, you know, stars, gas, the stuff you can actually see, it comes out to about 1/3 of the total that we expected. In most large spiral galaxies, dark matter dominates. Andromeda has a clear deficit compared to everything else cosmology predicts. In plain language, we're missing dark matter, Kyle. Where is it? Where are the particles? Alright, I've basically locked you in a single pose for this whole journey. Oh man, you thought you could just transform whenever you wanted. Now you know I am you and you are me. Nah, you've got much to learn and prove, just like the galaxy that proved dark matter exists and appears to be missing it according to this study. Then it gets even weirder. NASA also detected an intense burst of gamma rays coming from Andromeda's core. Gamma rays are the most energetic form of light possible and are what you'd expect to see if dark matter particles were colliding and annihilating each other, which would mean that dark matter is there, but it's just concentrated in the center. However, that could also just be a dense cluster of pulsars producing a similar signal. We genuinely cannot tell from 2.5 million light years away. So either Andromeda has a dark matter problem, or it has a mysterious gamma ray source at its core that no one can explain. Then we're going to try and find out together.
Stage 5 of the weirdness and the abnormalness of Andromeda.
So Andromeda has 37 satellite galaxies, basically little dwarf galaxies that orbit it like moons around a planet. Every cosmological model says that they should be spread evenly in every direction, but 36 out of 37 of them are on the same side and pointing directly at us. And not just us in the ship, Kyle, but the Milky Way and Earth. And also, not kind of pointing at us, literally all facing the Milky Way like they're watching. You know, like when I've been staring at you from a distance since my return, watching your weird routines and silly hobbies and habits, planning my move to take you to Andromeda. Now, American Bear is finally aboard. How did you like that warp drive jetpack? Neat, huh? Show me the simulations you ran. Ah, I see. Here it is, Kyle. Astronomers, and apparently American Bear, ran the dwarf galaxy data through standard cosmological simulations, the best models we have on how the universe forms galaxies. They asked, how often does a galaxy end up with smaller galaxies around it with such a lopsided pattern? Well, less than 0.3% of the time. Yeah, 0.3. And in those simulations, even the rare lopsided cases aren't as extreme as what we actually observe. None of the simulated galaxies matched Andromeda, not one that we have found in the universe. Wild! And then on top of that, half of those satellites orbit as a giant disk of dwarf galaxies, all moving together in a coordinated ring at the same level around Andromeda, like if you put M&Ms on a plastic plate and lean it to one side, which also shouldn't happen. So you've got satellites that are all on the wrong side and half of them are moving in formation. The paper in Nature Astronomy called it an extreme outlier in the prevailing cosmological paradigm, which is scientist language for we have absolutely no idea why this is happening and it makes us uncomfortable. Whatever is making it happen, we don't know what it is yet. Ah, finally we are here, we made it guys! Stage 6 of our journey, of strangeness, the Mystery Nebula. Just when you think you've covered everything strange about Andromeda, in 2023, 3 amateur astronomers were just casually scanning the sky and discovered a massive nebula right next to it. They called it SDSO-1. It's rich in oxygen, which is unusual enough on its own for a nebula, which is almost always mostly hydrogen and helium and stuff. But here's the shocker. There are no hydrogen filaments connecting it to Andromeda at all. No sign of what created it. No explanation for why it's there. Scientists looked at everything nearby for a source and found nothing. Current research can't even agree on whether it belongs to Andromeda or our galaxy or something in between. 3 amateurs with backyard equipment found something next to the most studied galaxy outside our own that nobody can explain. So we've been staring at Andromeda for over 100 years, Kyle, and we don't know everything about it. Just like you don't know everything about me. So yeah, this is where I'm going to leave you, by the way. I just want to test your gravity pull skills. You think you are me? You think you can take me on? Alright, but not before I give you a tip. Stage 7. Andromeda and the Milky Way might not collide, so I wouldn't think about taking too long to escape the Mystery Nebula. Bye-bye now! What's that, American Bear? Oh, the latest data on SDSO-1 suggests is literally in our galaxy? Then what weird mystery place that we know nothing about did we just leave Kyle in? No, the giant stellar stream? At least we know the collision between the Milky Way and Andromeda might not happen. Crazy, right? Since 2012, it has been treated as essentially certain. Andromeda and the Milky Way are heading towards each other, and in roughly 7.6 billion years, they will collide and merge into one giant elliptical galaxy, Milkdromeda. It was in textbooks, it was in documentaries, it was in gravity pull videos, but new data from the Gaia Space Telescope and Hubble changed everything. When the researchers ran new simulations of the trajectories of both galaxies accounting for the gravitational pull of the Large Magellanic Cloud next to us here in the Milky Way, which is actually pushing things around more than we realized, they found that there is roughly a 50% chance of Andromeda and the Milky Way simply missing each other, and a very low chance of a direct head-on collision. The thing everyone told you was inevitable might not happen at all, unlike what happened to actually allow the solar system to exist with all these anomalies around us.